All right, so today we're going to start our lesson off by going over some standards that you have already learned. These are going to be third grade standards. You have already learned this in third grade. It's just going to be a review. Hopefully it'll be a review. If you guys don't remember some of it, it's okay, because we're going to go back. We're going to go over this later in the year. But this is just stuff to help you remember what you've already learned in third grade. Now, I'm going to set the timer for 5 minutes. We're going to be going over classification of animals. This is a third grade standard. I'm going to ask the question and raise your hand if you know the answer. Okay, what are the two categories of animals? Two categories of animals. Raise your hand. Angelique.
Vertebrates.
And?
Invertebrates.
Invertebrates. What does invertebrate mean? Invertebrate. Neil.
Has no spine or backbone.
No spine or backbone. So what does vertebrates mean? Amber? It has a backbone or spine. You know, we have invertebrates. Invertebrates. In means not, sort of like invisible. Okay, not visible. Same thing with invertebrates. Okay, what are the 5 groups of vertebrates? 5 groups of vertebrates. Animals that have backbones. Let's see. Yes.
Reptiles.
Reptiles are one of them. What else? Go ahead. Got reptiles? Huh?
Birds.
Birds. Fish.
Mammals.
Mammals.
Amphibians.
Amphibians. Very good. That you can use that kind of as a guide. What are basic characteristics of mammals? At your table, I want you guys to figure out what the basic characteristics are mammals. Okay, ready, go.
No coat.
Okay, but what are the characteristics of a mammal? What makes a mammal a mammal? Okay, keep going.
They have live.
Okay, high five. Raise your hand if your group gets this one, okay? Raise your group if your group said warm-blooded animals. Okay, put your hands down. Raise your hand if your group said hair or fur. Good, hands down. Raise your hand if your group said live birth. Okay, hands down. What does it mean by live birth as opposed to dead birth, right? No, we don't have dead birth. So what do we mean by live birth? Live birth. Xavier?
When you give birth.
Right, they give birth, but what's the difference between what's live birth as opposed? Neil, do you try it?
When live birth is when the baby is alive, and the not live birth is when the animals lay eggs.
Okay, it's in an egg, okay? Get it? So it kind of develops inside of an egg. All right, very good. Who said breathe with lungs? Breathe air with their lungs. Okay, very good. Mammals breathe with their lungs. What about females feed their babies with milk? Very good. Okay, you're going to do it again. Let's see. What are the characteristics of reptiles? Reptiles. Ready, go. Work in your group.
When their babies are first, they breathe air. They have to.
Okay, high five. Try it again. Who said, raise your hand if you said cold-blooded animals. Cold-blooded, what does cold-blooded mean? They don't have warm blood, that's right. What else?
They're from the sea.
Not quite.
They don't have fur.
They don't have fur, but what does it mean when they're cold-blooded? Yes, Roy.
Their bodies can change temperature.
Okay, their bodies will stay the temperature of their surroundings. Like we are warm-blooded, we're a mammal, we're warm-blooded, so we can start shivering and stuff, and that makes us warm our bodies up when we get cold. But we can regulate our temperature. But cold-blooded animals are the temperature. Their inside body temperature is going to be the same temperature as the outside. So that's the reason why you have lizards that in the wintertime they'll sit out in the sun because they need to warm up. Okay? So very good question. Let's see. What about, did anybody say they have scales? Good. Hands down. Lay eggs. All right, they lay eggs. Hands down. Breathe with lungs. How do they breathe? They breathe with lungs. Reptiles breathe with lungs. Okay, what about, okay, now we're going to do for birds. Ready? Go. Characteristics of birds.
They have feathers. They lay eggs. They lay eggs. Yeah, they're warm bodied. Well, they don't have wings. Huh? Yeah,
Cold or warm?
they don't have
Very good, they're warm, they lay eggs. Xavier, you said, and then Pablo, you said. They
Okay, this is the last question. So, how are birds covered with what? Feathers. Are they cold or warm-blooded? Warm-blooded. Do they have live birth or lay eggs?
Lay eggs.
Very good. And do they breathe with gills or lungs? Lungs. We'll just hit, I think the last we had was, we had fish and amphibians. We'll go over that tomorrow, okay? Okay, so today we are going to be talking about good and bad conductors of heat and electricity. So that is what we're going to be talking about today. We're going to start off with our foldable, and we're going to cut it out and match it up, and then we're going to watch we're going to do the PowerPoint, and we're going to take notes on our foldable. So if we go turn the lights on there, we'll go ahead and get them out. Now remember, we're going to cut out all of the bordered pictures here, including the title. I want to cut it out as quickly as possible in 5 minutes or less. When you get it cut out, I want you to try and match up the pieces, just trying to figure out which ones go with what. Do not glue it down yet. We're going to discuss it to make sure we have them all right, okay? So I'm going to go ahead and hand these out. As soon as you get them, you can start cutting them out. Remember, this is not art class. You need to try to be somewhat neat about it, but it doesn't have to be perfect.
Everything with an order, including the benchmark right up here, okay? All right, Xavier.
Yeah. Now, some people will cut them cut them out as a big group instead of individually, and that's helpful. I like how Kevin here, he cuts like 3 out at a time and then he'll split them up. It's a good idea. Instead of trying to cut everything individually out. Just cut them all at the same all together. Good job. Now once you got them all cut out, you can start matching it up. All righty. 2 minutes to cutting. You should be matching them up by now. Now we are going to make a 2-tab vertical foldable. The way we do this, so wait for everybody to get yours matched up. So you're going to take your piece of paper. We're going to fold it hot dog or vertical. Nice and neatly, you're going to fold it. The hot dog fold. So it looks like this. Neil, you got one? Right here. It should look like this. Hold it up like a book for me when you're done. So it opens like a book. Okay? Now, I'm going to have you fold it down again and fold it on the top. You're going to take your scissor and just on the top one, just on the top piece, you're going to cut along that center line right here. Just like that. So we make it like a little book. And then you can put your scissors away because you don't need them anymore. Now on the front of this one, you can, I want you, what should we put on the front panel right here? Okay, right, let's do this. We can put the good conductors here, poor electrical conductors here. Go ahead and do that for me. Good and poor. Your title, watch this. We're going to bend it back down like this. You're going to put the title right here, because they'll have room for notes if we need to, okay? There you go. Okay, now let's look at what did you guys decide? What did you put down for good conductors? Good conductors, what did you say? Aluminum cans, what else? Metal and power lines. So they're good electrical conductors. Looking at those things, could you say those are good heat conductors too? Do you ever cook anything in aluminum?
Yes.
Yeah? Okay. I got aluminum pots at my house. I've got remember those little aluminum things that if you go to take something somewhere, you just want to throw them away? Okay, you cook in those things. All right. And what did you put as poor conductors? Glass, rubber tires, and plastic. So if those are good electrical conductors, poor electrical conductors, are these poor heat conductors too? Think about that. Think about the pots in your house. Like for your parents, your mom maybe cooks in. What are those handles made out of? Plastic. Why do you think they make plastic handles? So are you saying that maybe the plastic isn't as good a conductor of heat? Because that way, because the pot can be hot, but I can hold that plastic handle, can't I? So, whoa, so what did we just discover here? What did we just discover about conductors of electricity?
That good electrical conductors are good heat conductors too, and poor electrical conductors are poor heat conductors too.
Did you guys hear what Amber said there? Can you repeat what she just said a little louder for us?
Good electrical conductors they produce good heat conductors.
Okay.
And poor electrical conductors produce poor heat conductors.
So there you go. So good, just from doing this, we realized that we can make that connection. That good electrical conductors are also good heat conductors, and poor electrical conductors are also poor heat conductors. Very cool. Now, what I'd like for you to do is when you open your thing up, on one of the panels, I don't care which one you do, on one of the panels, put all of your good electrical conductors on one panel and your poor conductors on the other panel. So we have a place for notes, okay? So go ahead and quickly glue that down. And if you have to overlap some of those pictures, it's fine, okay? If they don't fit in there all the way.
Good. Go in right here. Nice. And you all the way to the front. Another. That's a good conductor. Rubber tires.
Now, if some of your pictures end up overlapping, that's perfectly okay, but you want to kind of put them way up in the corner there so you'll be able to have room, okay? Yes. That's not any good. Let's see, why don't you use this right here?
Close this tab.
Just use a little dot of that. Okay? So read we're going to read our standard together. So everybody look at the standard. We're going to read it. I'm going to read it kind of slowly so you guys don't like take off and run away on me, okay? So we're going to read it together. Investigate and explain that an electrically charged object can attract an uncharged object and can either attract or repel another charged object without any contact between the objects. That's a lot of words in there. Anybody have any idea what we just read? Okay, well, let's just break it down. How about that? So we said electrically charged objects can attract an uncharged object. Okay, so somebody tell me a situation where we might have objects that attract each other. Xavier.
Two opposite sides of a magnet.
Two opposite sides of a magnet. Very good. So those are attracting each other. And the opposite sides are usually what? What are the poles called?
North and south.
North and south. Well, electricity can do that too. Electricity can attract itself. And so we have charges. And those charges are, anybody know what the charges are? Think about a battery. What's on a battery? The plus and the minus, which is positive and negative. So those are positive and negative charges. Okay, so let's read this again with that background knowledge, okay? Investigate and explain that an electrically charged object can attract an uncharged object. Okay, stop there. So do you get it now? An electrically charged object that either a positive or negative charge on it can attract or repel another object. Got that? No? Yeah, okay, all right. So, and it says here that it can attract or repel another charged object without any contact between the objects. Can anybody think of a time when maybe you personally used an electrical charge on something and not even touch somebody? You ever charged somebody?
When you rub your hand on something like plastic, I usually when you touch when you're close to someone, it shocks them.
You shock them. So you have a lot of times it's in the wintertime when it's cold and you rub your feet on the floor and then you come up and you touch the car. I used to shock myself every time in the wintertime when I'd touch my car door and it would shock me. Okay, or you'd shock somebody else, and you don't even have to be near them sometimes. You don't even have to touch them. You might get close enough and shock them. So that's static electricity, and that's when you become the electrically charged object, and you're touching something else. Here's another example of that. So you ever take a balloon? Can you turn off? Yeah. You ever take a balloon and rub it? Well, this is wool. Wool does this really good. So you rub it with wool. Okay, so I've just used that wool and I've put a charge on this balloon. Now watch, I've got this piece of tissue paper. I'm not moving it. Look at that. See that right there? See it?
It's like a magnet.
It's like a magnet. What's happening? Let's use the vocabulary we're just learning about. What's happened here?
It's attracting it.
It's attracting it. What is attracting it? Is this a magnet and this is a magnet? No, what's going on here?
The balloon's a magnet.
There's electricity. Which one is, so we've got, which one is charged? Which one is charged?
The balloon.
The balloon. And so it is attracting this other uncharged object. Look at that. Am I touching it?
No.
So let's look at this standard again. Can you turn that light off again? Let's look at the standard again. Let's read it again. Investigate and explain that an electrically charged object can attract an uncharged object and can either attract or repel another charged object without any contact between the objects. Balloon. Cool, huh? So we're going to learn a little bit more about that later, how to make another electrically charged object. And right here, this is the next part of it. Identify, read it with me. Identify and classify materials that conduct electricity and materials that do not. So our foldable has a lot of that on there, but this is part of the standard we're going to learn about. And I will tell you this, our speed bag drawing is going to have something to do with this too. So we are talking about conduction. Conduction, we've just mentioned about how heat and things that conduct electricity will also conduct heat. So we're going to kind of mash that all together today. So conduction is heat transfer that occurs when there is direct contact between objects. So like on a stove, you have your stove that sits right on top of the burner, and you have direct contact, and that's conduction. So let me read this that goes along with this slide. Listen carefully. Conduction is heat transfer that occurs when there is direct contact between objects. Heat flows from objects with higher temperatures to objects with lower temperatures. The rapid movement of molecules of warmer objects collide with the slower moving molecules of cooler objects. Heat transfer continues to occur from molecule to molecule until both objects are the same temperature. So we have conduction. We're talking about an object that is from a higher temperature to a lower temperature. Let's all think about, I like winter, so let's think about hot chocolate. It's way too hot right now for hot chocolate, I think. But when you take your hot chocolate and pour it into a cup out of the cabinet, okay, out of a mug, after a couple of minutes, what happens to that mug?
It turns hot.
Why does it get hot? Because of what? Conduction. Explain that to me. What's happening?
The hot chocolate is giving off heat to the mug, and it's making it hot.
Okay, so the hot chocolate is giving off heat to the mug, and it's becoming hot. So Neil, can you explain that on a molecular level for me?
When the hot chocolate goes in the mug, the temperature is lower, so the heatness it'll make the mug the same temperature as the hot chocolate.
Okay, so how does that work on a molecular level? Let's think back. So our molecules always moving, whether it's a solid, a liquid, or a gas. Would you agree with that?
Yes.
So it's solid. So the mug has molecules that are moving, just not very fast because it's also cool, right? So I pour that hot chocolate in the mug, and I'm hot chocolate, and Angelique right here, she's the cool mug. Okay, so and I'm moving all around because I've got all these molecules. I'm hot because molecules moving around are hot. So I'm moving around and I touch Angelique, and so what happens when I'm touching Angelique? Okay, she starts moving too, right? I'm bouncing into her molecules, and her molecules will start moving. And so then she becomes the same temperature as what's in the mug. So what happens to that mug after we sit it on our kitchen counter for about an hour or so? Huh? After I sit it on the counter for about an hour or two, what happens to that hot chocolate in there? It cools off. It cools off to what temperature? The air around it, because isn't the mug touching the air? And so it's going to go from a higher temperature to a lower temperature until it equals out. So that's why you can put a cup of hot chocolate or a cup of coffee on the counter. Your mom or dad ever forget where they put their coffee? Somewhere in the house? I do that all the time. Like, where did that coffee go? By the time I find it, it's cold, because all those molecules inside that coffee have all slowed down because they have all become the same temperature as the air in my house. So we are talking about that. So let's talk about what should we write down from this slide right here. What should we write? Probably write this definition. So why don't you do that? We're going to put that in the good conductors, electrical conductors. We're going to talk about, because we talked about how good heat conductors are also good electrical conductors. So conduction, heat transfer that occurs when it comes in direct contact between objects. And I also want you to write this down. And I want you to write good heat conductor equals good electrical conductor. Now, as we go through these slides, I want you to be thinking about vocabulary that we come in contact with. And if there's a vocabulary word that you think, you know what, I might need to know a little bit more about that vocabulary word, why don't you put a star by it or underline it or write it down somewhere? So, because at the end, we're going to make a list of vocabulary words that you as a class decided that, hey, I might need to learn a little bit more about this vocabulary word. And then by the end of it, we'll look at that each day. And then hopefully each day we'll say, you know what, I don't need to have that up there because I understand it now. So we'll erase them as we go. So just think about that as we go. Now I want you to write the definition of conductor. All electrical conductors are good conductors of heat. We already discussed that earlier. All electrical conductors are also good conductors of heat. So we just put that in the same thing. We have silver, copper, gold, heat, and aluminum. Now these are good conductors of heat, but they're also good conductors of electricity. Did you know gold wasn't a good conductor? Silver is actually one of the best conductors of electricity, but I think it would be pretty expensive to wire my house in silver wire, wouldn't it? So does anybody know what we normally have wiring in buildings? Xavier?
Copper.
Copper, that's right. Copper is the one that we use mostly. Some metals are better heat conductors than others. For example, silver is the best conductor of heat, followed by copper, then gold, and aluminum. Now, solid substances are better conductors than liquids, and liquids are better conductors than gas. So what should we put for these conductors here? Should we write this down somewhere?
Yes.
Yeah, why don't we write this down on the good conductors thing? Silver, copper, gold, aluminum, heat. Why don't you write those down on the good conductors side? So now, poor conductors of heat. Materials which do not conduct heat well are called insulators. Non-metals are poor conductors of heat and electricity. Fluids and gases, including the air we breathe, do not conduct heat well. Rubber, plastic, ceramic, and foam are excellent insulators of heat. Electrical insulators like glass, wood, or Teflon are also insulators of heat. So what should we write here? What should we write down here for poor conductors? And that, anybody know? Is there a vocabulary word in here that I'm like, hey, we really need to write this thing down? Insulators. So write down insulators equals what? Huh? Okay, well, materials that do not conduct heat or electricity well. Insulators, materials that do not conduct heat or electricity well. So non-metals are poor conductors of heat, electricity. We have rubber tires, plastic bottles, and ceramic, which is what the coffee cup. It does keep it cool for a while, but it does eventually warm up, doesn't it? Mm-hmm. So that's why we do use mugs and then we have the handle and everything, right? Now, what else did we talk about? What are some things that are poor conductors that we talked about? Yes, Neil?
Air.
Air. Okay, you can write these down, okay? Add these. Air. What else is a poor conductor of heat? Foam. Foam. Think about the, your coffee cups, foam cups. They put hot coffee in. What about wood? I know I have an old-fashioned pot for my stove. It's aluminum, and it has a wooden handle on it. They put a wooden handle on it because back when this pot was made, they didn't have plastic. So they would use wood for the handle because it's a poor conductor of heat. So I need you to take out your journal, open up your journal, and we are going to put this in your journal. So I think you're on page 20. You're going to make it look like this, folks. See how this is right here? You're going to make it look like this. Oops, fold it over like, no, you want it to look like this. Hold on. So make it look like this one. You're going to open it up. You're going to fold it over. You're going to glue it in like that. Be a boss. Show who's boss here.
Remember, a little goes the wrong way.
There you go. Now, on the other side here, we're going to do our 4, 3, 2, 1. We're going to draw a line top to bottom, side to side in our book. Top to bottom, side to side. We're going to number it 4, 3, 2, 1. So we talked about a lot of different things today, didn't we? So first of all, let's go review. What does the 4 stand for in our 4, 3, 2, 1?
At least
4 vocabulary words. What does the 3 stand for, Aurora? 3 student-generated questions. What does the 2 stand for? 2 interesting facts. And what does the 1 stand for? What'd you say, Xavier? 1 summary. So right now, let's talk about interesting facts, because we talked about a lot of things. So did anybody want to throw out there, what's some interesting facts we learned today? Xavier?
We learned about how good electrical conductors and poor electrical.
Okay. Amber, what interesting fact did you learn today?
That good electrical conductors are also good heat conductors.
She said good electrical conductors are good heat conductors. Anybody else learn another interesting fact that we had today? Another interesting fact. Yes. Do you have your hand up? Go ahead.
Electricity flows through conductors but not through insulators.
Electricity flows through conductors and not insulators. Very good. Did you have an interesting fact?
Poor electrical conductors produce poor electrical.
Well, they are, yes, they are. So poor electrical conductors are poor heat conductors. So those are awesome. Neil, you got another one?
Yes. If you increase the temperature, good metal conductors will conduct electricity poor.
He said, say that again.
If
You increase the temperature of a metal,
it'll conduct electricity poorly.
it'll cause it to conduct electricity poorly. Very good. So of all those things, maybe you've thought of another one. I want you to write 2 interesting facts. 2 interesting facts. We've talked about a lot of them. So as I talked to you guys about vocabulary words. So what vocabulary words, now this is the group, this is the last class is their vocabulary. So at your table, look through your books and talk at your table, what are some vocabulary words that maybe we need to write on the board here so that we can be thinking about that and making sure we understand them. Anybody, Angelique?
Insulator.
Insulator, okay. What else? Anybody else have another one? What goes with insulators? Conductors. How about we do conductors up there? Anything else? We talked about attract and repel. Do we need to put attract and repel up there? Do you think, or does everybody understand what attract and repel is? What does repel mean? To push away. What does attract mean? To come together. Do we need to write that up there? You think so? No? Yes? No? No? Okay. What else? Is there something else that we ought to write up there? The other group said conductivity. Should we write conductivity up there? Okay. And the other class had charged, electrically charged and uncharged. Do you understand what that means? Or should I write that up there? We have a pretty good understanding of that? We'll leave it at that for right now. Now, tomorrow, as we go through our book, you may decide that this might be some words that you might want to use. You may want to think of some other ones, okay? So those vocabulary words, and some of you guys are writing these down, and that's fine. but we might come in contact with some other vocabulary that you might want to look at too. So we'll be doing that tomorrow, and we're going to be doing our speed bag book. Did anybody come up with a interesting fact that we didn't talk about, that we didn't mention, or did you guys just kind of decided to use what we kind of together as a group decided on? Okay, very good. All right, you guys can go ahead and put your books away. Yeah, Xavier.